Hello again. This is the next video on for the moments topic, looking at what happens when something that you're sat on is about to flip over. These problems are generally known as tilting problems. So what we're looking at is this kind of situation. We have a bench, and we've got someone sitting on the end of the bench. Now, maybe this bench is not very heavy, or this individual is. He sits down, or they sit down, and they're going to fall down that way, because the bench is going to turn. So this end of the bench is going to go this way, this end of the bench is going to go this way, and he's going to end up sprawled on the floor. But in terms of mechanics, what does this mean? Well, this individual, as we know, has weight. So there's a force going down this way. Here, we're still on two supports, two rests, and they have reaction forces. Now, once this bench goes, we only have one point of contact, this reaction force here, or this point of contact. So this has a reaction force. We no longer have a reaction force here, so it doesn't exist. But what happens if we're here and we're just balancing? Just enough so that if this person weighs any more, then it goes. We're just resting on here. Now, if you can try this at home. If you take a ruler and pop it on two fingers like that, get someone to stick weights on the end, or something on the end, until it flips. What you'll feel is that on this finger, it's kind of, the ruler just starts to almost hover in front of it. So when it is about to tilt, when a rigid body, which is what we call this kind of topic, because it is static rigid bodies, static because things aren't moving, rigid because they don't bend. So when it's on the point of tilting, the reaction force at all other supports equals 0. So R2 here will have a value because we are pivoting around this point. This reaction force is 0. If we had another rest here and we're on the point of tilting, this reaction force would also be 0. So regardless of how many supports we put on this side, if it is on the point of tilting about this point, all of the reaction forces are 0. Everything else to do with the actual problem-solving element of this topic works exactly the same way as the previous two videos. Resolving forces, resolve moments, see what happens. So what we're going to do is we're going to look at the example 3, which is on page 2 of the workbook. Okay, so this is the example we're working through. We can see we've got a bench is constructed from a plank of length 5 meters and weight 150 newtons, supported on blocks 1 meter from each end. The bench can be modeled as a uniform rod resting on smooth supports. Find the maximum weight of a person who sits on the end of the bench if the bench remains in equilibrium. So, the fact that it says remains in equilibrium here and maximum weight, those two bits of information together tell you it is tilting, or it is on the point of tilting. Okay, so the fact that it's talking about the maximum weight, and maximum weight, not mass, so careful with your how you give your answer. Let's start by doing what we always do, draw a diagram. Okay, so a bench is constructed from a plank of length 5 meters and weight 150 newtons, supported on blocks 1 meter from each end. So we have our bench, our dimensions, and we know that the center of mass is in the middle. Whoops. How do we know the center of mass is in the middle? It is a uniform rod. Okay, so don't forget, that's something else they could do to make this a little more difficult, is make the rod non-uniform. Okay, smooth supports just needs to be there. It means we don't have to worry about any frictional force happening here. Now, because this is entirely symmetrical, it doesn't matter which end the person sits on. If it's not symmetrical, you'll be told which end to use. So, for the sake of argument, I'm just going to use this end here. Just so I've got more space. Now, we're only interested in the weight of the person, so let's not worry about calling it mg. Let's just call it W for weight. So, what else do we know? Well, we know the reaction force here is 0. Okay, because it's about to tilt here. Don't forget, it remains in equilibrium, but we're looking at the maximum weight, so it's about to turn. And we have a reaction force here. Why is this reaction force irrelevant? Well, it's about to tilt about this point. So we're going to take moments about here. Okay, if we take moments about the right-hand support, remember, moments are force times perpendicular distance. The distance from this force to this pivot is 0, so the moment caused by this force is 0. Okay, so remember, because we're rotating about this point, this force is going to cause an anti-clockwise moment. This force is going to cause a clockwise moment, but it's in equilibrium. So, this force times this distance here is equal to this force times the distance. So the weight, so W, is 150 times 1.5, which is 225 newtons. So this is the maximum weight because we've said that this force is 0. If this force isn't 0, if this is more than 0, then it's not on the point of tilting, so this is not the maximum weight. If the weight is any more than this, then the resultant moment will not be 0, okay? Because it will then move. So therefore, the maximum weight is 225 newtons. Again, be careful. We've asked for the maximum weight, not maximum mass. If it was maximum mass, you take this and divide it by 9.8 and get the mass of the person. It's all about answering the question. So this is the key idea, that the point of tilting the reaction force at any other pivot is 0. Beyond that, as you can see, it's a case of doing exactly what we've done. Resolving moments, maybe resolving forces, depending on what the question needs. So, to practice this, exercise 4E is on page 84. Questions 1, 2, 5, and 6. It's not a particularly long exercise, so